Audio Jungle.
Good morning, everyone. This is Shiba J. Sophia, Assistant Professor, EC Department. In this session, we are going to discuss about a new domain, a new subject, communication theory. Before moving into the subject, first let us get a brief intro of what is meant by this communication. We all know that communication is nothing but transferring or sharing the information between two persons or points. So in this subject, we will be learning about what are all the concepts which are used for sharing of this information and how it can be effectively communicated without noise. Totally in these 5 units, we will be learning all these concepts. The Unit 1 mainly covers the amplitude modulation concepts, and Unit 2 angle modulation, Unit 3 regarding the random process that are available, Unit 4 for reducing the noise characterization, and Unit 5 sampling and quantization. Totally, by covering these 5 units, we will be learning about the concepts of modulation, random process and noise performance, and we will be gaining the knowledge in sampling and quantization too. Hereby I have shared the textbook and reference book for your kind reference. And I have also given the NPTEL lecture material references links for both video as well as the materials. Moving to the introduction, modulation. Modulation is the process by which some parameter of a carrier signal is varied in accordance with message signal. The message signal is called a modulating signal, and the carrier signal usually a simple sine wave that contains no information in itself. This gives 3 possibilities of modulation, namely amplitude modulation where amplitude of the carrier is varied, frequency modulation where frequency is varied, and phase modulation where phase of the signal is varied. It actually turns that FM and PM are very close to each other. The amplitude modulation, as I have mentioned, the amplitude of the carrier is varied and according with the modulating or message signal. And so here we can represent the unmodulated carrier signal as S of t is equal to A cos 2 pi FCT. For carrier signal, SC of t is equal to A of t cos of theta of t. Here this theta of t is the angular, which is the instantaneous phase deviation. For amplitude modulation, this A of t is the instantaneous amplitude. So depending upon the relationship between the M of t and A of t, we can have the types of modulation schemes like normal modulation, that is amplitude modulation, double sideband suppressed carrier DSBSC, single sideband suppressed carrier SSBSC, vestigial sideband VSB modulation. In normal amplitude modulation, that is double sideband large carrier DSBLC, the S of t is equal to carrier plus 2 sidebands. So here it has 3 terms. The modulation index, which is one of the most important term in this modulation, it is defined as the ratio of amplitude of modulating signal to that of unmodulated carrier. Its value actually ranges between 0 to 1. If it is equal to 0, there is no modulation, and it is equal to 1, there is the maximum modulation. So, if the modulating signal lies between these two values, it is a prominent value. That is, it is 3 categories like critical modulation, under modulation and over modulation based on the value of this modulation index. And by finding the power value of the signal PT, that is total power, we find that power value decides the percentage and how efficient this modulation is. If several modulation frequencies occur at the same time, we can take it as mt is equal to, that is total modulation index is equal to square root of m1 square, m2 square plus m3 square up to mn square. As I have said, this is the graphical representation of this signal modulated output. The spectrum of the normal signal, that is SE of t, is equal to 0.5 into a bracket del of f minus fc plus del of f plus fc, and it goes on. The spectrum of this normal AM signal is depicted in this graphical representation, and the efficiency eta is equal to PS, that is power carried by the sidebands divided by PT, total power, into 100%. Generation of normal AM signals can be done by any of these few methods like square law modulator. In the square law diode modulation, it makes use of non-linear current voltage characteristics of a diode, which is clearly given in the diagram. It has band pass filter for filtering out the effective needed components. If we pass the signal, that is V naught of t through a band pass filter centered at plus or minus fc, then we obtain this V naught of t as A is equal to A divided by 2B terms. That is a normal AM signal with the two sidebands is generated. Another type is the switching modulator. A normal amplitude modulated signal can also be obtained by multiplying the signal m of t by a periodic signal s of t. The modulator here is said to be switching modulator. So if we take a periodic rectangular waveform s of t of period tc is equal to 1 by fc and amplitude am and pulse width tau, it can be depicted as given below, and the coefficient c naught is equal to am into tau. The corresponding complex Fourier series, that is s of t, is also given. This is the graphical representation of line spectrum of s of t. Based on the input signal given, the output of switching modulator can be varied. And so, in here, V naught of t contains a DC term, a component m of t, and an infinite number of normal AM signals at carrier frequencies. So, the output here obtained is a normal AM signal. So, when moving to the demodulation of this normal AM signal, we have some terms like detection and demodulation. That is, the process of recovering the message signal from the modulated signal is called demodulation or detection. Here also two basic methods are available for demodulation. First one is the envelope detection. In this method, an envelope detector is used to recover the message signal. An envelope detector consists of a diode and a resistor capacitor combination, which you can clearly see from the circuit diagram given. During the positive half cycles peaks of the modulated signal, diode is forward bias and capacitor charges up to the peak value. And as the modulated signal falls from its maximum, the diode turns off and the capacitor discharges through the resistor. The process repeats in this way. For proper operation, the discharge time RC must be chosen properly. Second one is the synchronous coherent detection. Here, product detector is used to convert the bandpass signal to baseband, as you can see in the diagram. At the receiving end, the bandpass signal is multiplied by a locally generated carrier signal. And so, the output obtained in the multiplier is as follows. If we suppress the first term by a low pass filter, we get y of t is equal to 0.5 a into cos pi naught plus 0.5 m of t into cos pi naught. It can be seen that we can recover the component m of t if the initial phase phi naught is constant and small. So this is the local carrier generated and the multiplier output for that. So if we suppress this first term on the low pass filter, we will get the output as follows, and the synchronous detection is sometimes also said to be coherent detection, because the local carrier must not only be the same frequency but be synchronized in phase with the carrier signal. So if the carrier shift in frequency or phase, the resultant signal is distorted or attenuated. And this is about the AM modulation and demodulation. So what are the methods that can be used for amplitude modulated signal modulation as well as the demodulation? So the main questions from this topic can be, what is the AM modulation, how it is implemented, what is the purpose of AM modulated signal, and what is the percentage of modulation that can be obtained and modulation index, and also regarding the modulators and demodulators that are available. This is about the content of presentation which we have seen. If you have any doubts in this, you can ask me and get the details. Thank you.